All right, so here's another example for class 23, and it's not nearly as much fun as the hovercraft one. I still miss me some hovercraft. Anyway, we have this rod, and it's initially held in place. So we're holding this with our little hands, and we somehow get these discs spinning, right? Maybe we have maybe just like a little a bolt or something here on the end, and we put a drill and we get that thing moving at 5 radians per second, right? And we give each of these discs that 5 radians per second, and they're both going clockwise. And then we let go of this bar. Well, what's going to happen is, well, first off, there's going to be a little bit of friction. I think the little bit of friction has to take place, but this thing will have some influence and will make this thing start spinning, right? The whole thing will start to spin, and then eventually the discs will end up spinning at the same rate as the bar. And here's another instance where, man, I'd sure like to try this out. This was from another book where they give us this information that it's going to happen right there. So, but eventually those whole things are going to come to the same angular velocity. And I kind of thinking back at it now that I think about it, you might actually want to have friction at these axles right there. But anyway, we happen to know the mass moment of inertia because we know that the rod is 2 kilograms and we know its length of 1.5 because there's 0.75 each on here. So we get the mass moment of inertia of the rod, right? And then we can get the mass moment of inertia of each of these discs because we have the radius and we have the mass. They're 4 kilograms each. They're pretty heavy. And anyway, we get them spinning. And when the relative velocity is 0, right, that means that both of the that omega A, omega B, and omega ABC, they're all equal to omega 2, right? And not only that, but the velocity of A and the velocity of B, they're going to be equal to that omega 2 times RAC, or the distance right there, that 0.75, yes, that 0.75 right there. That's what we mean by RA with respect to C. We mean the middle by C. So here is our momentum, the before, impulse, and after, right? And we should have labeled these right here. It's like that we got to go before, and then impulse, and then after. And we might note that the impulse right here, the angular impulse, if we're taking about the center, about C, is going to cancel each other out because they both have the same mass, right? So there you go. There's the before, something happens to it, and after. And so we have, here's the before. It's going to be completely the little wheels spinning, and in this case I decided, because everything was going clockwise, to finally make clockwise positive just so that we didn't have a bunch of negative signs everywhere. But when we're done, we're going to have the bar moving, and we're going to have each of the discs moving, but also they're going to be having these these linear momentum that's happening, but it's happening at a distance away from the center. So plug in some numbers in, and all the external moments, impulses are 0 because they all cancel out right here. So that guy goes to 0. And we plug some numbers in, and sure enough, it's going pretty slow actually. So it's almost kind of like the reverse problem in some ways of thinking about it, of what took place in the previous example, in the hovercraft example. And once again, I'd like to actually build this and try this out, right? To somehow get these things spinning up at that rate, right? I'm going to take a couple people doing it, right, to hold the thing in place, and maybe we get a couple drills and construct this thing. And I have a 3D printer, so maybe I should ought to make one, right? Ought to make this thing and then run a demo. But anyway, that would be a cool thing to do. Just try to actually put some numbers against this. And thank you very much. And by the way, I think we could use work and energy on this? Maybe. Yeah, I think so. I think there's nothing stopping you. Thank you.